Good morning and good afternoon to everyone uh, attending this Oxford Flow hosted webinar on emissions, hydrogen and energy transition for the next generation of gas. I'm your host, Faris Churcher, and I'll be going through this webinar with yourselves today. So first of all, thanks very much everyone for your time today. So a little bit of agenda for today. I'll start off with some introduction. Firstly, into the kind of presentation itself. So, what are emissions? Why do we care about them? What are the wider? Why is it in the news? Why are we taking an entire hour? Sorry, that would be depressing. An entire hour out of your day to talk about them, and why is everyone getting so involved with it? Going on to that, what is hydrogen? Why is that so important as well? And why is seemingly every day a new story on hydrogen, conferences and hydrogen production and hydrogen storage and transport? Why is that all happening? And what is being done to make sure that this kind of energy transition can go forwards? So, without further ado, I'll move on. We'll start off with a few introductions. So, first of all, our hosts, who are Oxford Flow? So Oxford Flow are a manufacturer of flow control and pressure control devices, spun out of Oxford University in 2015. Obviously, since then, we have done a huge amount of work throughout the world in a lot of different industries. We started out in water distribution, sorting out a lot of problems for UK water companies. Obviously, those of you who are based in the UK and have read the news recently know that one of the UK's largest, or the UK's largest water supplier, Thames Water, is running into some issues with its own debt, but I'm not going to get into that so far. We started out in water, but now work in energy systems, gas transmission, energy transmission, I should say, and upstream oil and gas as well. But we are very, very heavily getting involved with the hydrogen side of things as well, and going forward from there. So, as I say, Oxford University has been around since 2015. The span out of Oxford University. So, the founder of the company is this man over here, Professor Tom Povey. He came up with this revolutionary design of pressure regulator because he threw out the rule book for how you should design a pressure regulator or control valve and came up with his own design. And now this range has extended from this first item that you see over here on the right to a rather large range, an extended range of pressure and flow control devices, along with some accessories that are proven and ready for the energy transition. So we start off with a little bit of a product overview as well. Just again, a little bit of background to what Oxford Flow does. So we've got three kind of major product lines: the ES series axial control and isolation valves, the IM series of gas regulators, and then the IP series of liquid regulators used for water, oil, or any other process fluid like that. All of these products have auxiliary products and variants, so I won't go too far into the details. These are all on our website, which details will be shown later on in the presentation as well. So, what is going on? Why is everyone here? Why is everyone tuned into this webinar today? So I'll start off with a few questions and then the answers, to those going forward. So first of all, what has happened? Traditional forms of energy are running out. So oil and gas reserves, fossil fuels are running out. That is a fact. There may be a lot left, but they will run out at some point. And the extraction and processing of that equipment, that fuel, is causing and has caused irreparable damage to the planet. And the UK, this came out, I think, yesterday. The UK is currently missing all of its targets, according to the Climate Change Committee. So, lots of things have to change in order for the world to carry on and in a healthy and sustainable way. So what really caused this to happen? I'm coming from a very Oxford Flow and innovative flow control and pressure regulation manufacturer, is that there really has been a lack of innovation for a very long time, a kind of real will to perform step changes in designs and operations. So that's kind of what's happened. There's yes to innovation, but no to change, which the two can't really go hand in hand. We, as an entire planet, as an entire population, have formed a very heavy reliance on fossil fuels as well. So here we are, and we can't just stop the taps. That just can't happen for lots and lots of reasons, and no one, especially us, is saying that we should. But there are also world events, and I've shown a picture of the Russia-Ukraine war currently going on that has seriously affected energy supplies all over the world. Much more than that, but I won't get into the politics of that today. So what does all of this mean? If nothing is done, I think it's very, very obvious. If we carry on in the way that we are, then there will be serious and long-lasting consequences. But it is up to us. It's this generation that has to do something about this situation. All the change has to come from today, from now. The report issued by the Climate Change Committee stressed this very much so, especially is that there is no real drive to get these commitments over the line. So that really, really has to change. So going on, what is actually being done now? So, I've put down listed some items here. So there are emissions reduction policies, net zero policies, carbon offsetting, but more importantly, those searches into alternative fuels, alternative transport, shipping, food, investment. There is a huge amount of investment going into low carbon technologies and renewables, but then also just spreading the word in conferences and exhibitions. So that's all a lot of money, and it's a lot of talk. And I just had a quick Google of conferences and exhibitions around renewables and hydrogen, and you just cannot breathe for hydrogen conferences and hydrogen technology shows and renewables like that. So things are happening, but conferences and exhibitions are one thing, and going ahead with a transition is another. But that said, I've said we can't just turn off the taps for oil and gas and fossil fuels, because they do contribute a lot to our day-to-day power and electricity. And this is a forecast from Total Energies. All references will be available later on. And this is showing the kind of requirements in 2050 for oil and gas, so fossil fuels. And they've not really reduced that much. In fact, they've grown as a proportion of the entire energy mix. And there are plenty of different scenarios for energy mixes by 2050, depending on which way you go. But we're not going to get into the details of that during this webinar. We don't have the solutions. So this is a comment to just carry on with that. No, this is a webinar not on how to address everything going on in the world. Oxenflow is an equipment manufacturer, and we will focus on the differences that Oxenflow can make. For everything else, there are alternative advisors available. I don't have the contact details, but there we are. So let's kind of bring this into focus now. So we are focusing on emissions, hydrogen, and general renewable tech. That's not to take focus away from any one of those three. And I'll be very clear in that there is no silver bullet to any of these issues. Doing one, solving the emissions crisis will not solve the rest of the energy crisis or anything like that. However, there are solutions around, products and technologies that will make that collective effort easier through, first of all, marginal gains. Reducing emissions step by step or cutting them away entirely will make the transition away from fossil fuels over to hydrogen, to renewables, to anything else quite a lot easier. But as I said before, it is a collective effort. Not just equipment manufacturers will have to get involved here. It is governments, it is users, it's consumers, it's other producers as well. So team effort, but it's going to take a lot of effort. But marginal gains and step changes are the little ways forward. So we'll focus on the emissions and hydrogen and renewables, but also on the products, those like these solutions and where they can fit to make the systems where Oxford Flow fits in, petrochemical, energy utility systems, where they fit into the net zero age, and how can we carry on with those? How can we make them fit for purpose going forwards? So, as I say, we have a line of products that are available that we want to kind of make sure that people are aware of, because they can help with this kind of with all three of these kind of major points: emissions, hydrogen, and renewables. So we've obviously gone through the core product line, but we've also got cutaways here, just exactly what we're doing here, which is so different to what anyone else is doing, especially in pressure regulation and isolation and control valves as well. So just breaking down those first 3 points, we start off with emissions. Why are emissions important? And first of all, what are emissions? I'm sure I'm preaching to the choir here. There's a lot of people who want to know the answers straight away, but there are also probably people on this call who are very new to this as well. So forgive me if I start from the beginning. So what are emissions? Production and discharge of something, especially gas or radiation. So that is very broad. And specifically what we are talking about today is fugitive emissions, and that has a slightly different definition. Emissions in general can be applied to anything. So, cars to a leak of water out of the utility system. But fugitive emissions is very, very particular to process industries. That is defined as the unintentional and undesirable emission, leakage, or discharge of gases or vapors from pressure-taining equipment or facilities. So that is very, very topical to what we do here at Oxford Flow in producing pressurized equipment, pressure-containing equipment that goes into a lot of process facilities and utility facilities as well. So one of the main things that we found the other day is that this came out actually in April of 2023, the US oil and gas industry is emitting 70% more methane than the Environmental Protection Agency estimated previously. So that is a reasonably worrying estimate. I've got an image here of just a standard control valve, a common or garden control valve, and where common fugitive emissions come from. And you'll notice just around here, this kind of vertical item here, that's where there are two forms of emissions there, and that actually comes from a Environmental Protection Agency report that said a typical facility basically listed all of the pieces of equipment within a typical facility. There's a wider report here which you can all click on and read yourselves over here. That's linked within this. But pumps, valves, connectors, lines, relief valves, average controlled, uncontrolled emissions in tons per year, 62% of which comes from valves. So that is pretty telling in itself. Obviously, joints, that's a major point as well, 31%. And that is really telling. But of those valves, 80% of the 62%, which let me do that maths, and I'll leave you to do that maths on your own, 80% of that 62% comes from the stems of the valve. So this vertical component here, which slides up and down, or radially for a ball valve or anything like that, that is where most emissions come from, which is really very telling. What does that actually lead to within these systems, within valves especially? Causes and consequences. So we get things like gearing failure, stem damage, packing failures, drivetrain failures. I realise we're getting slightly too into the weeds here for a lot of people, but lots of you are control valve and regulator specialists. So this is what can happen. Drive trains, seat damage from high velocity flows, and also main diaphragm failures from pressure regulators. And this is what you see. Drivetrain damage can be pretty catastrophic. Stem corrosion, but then this is the end result of fugitive emissions. It is incredibly, this can be harmful gas, harmful liquids, harmful materials. We don't want that leaking outside of a valve and causing greenhouse gas effects. And the consequence of this is obviously, in the end, loss of valve control, which will lead to excessive maintenance activity. And then, obviously, fugitive emissions. So what do we do about all of this? This is a major issue because every time a valve loses control and needs to come, technicians have to come and maintain it. That requires the venting of a line, or it requires a shutdown of some section to maintain the valve itself, which all requires venting of gas or venting of some fluid within the line. So how do we get around that? How do we stop the valves from failing? How do we then, as a result, reduce that maintenance activity? Granted, some people have to do yearly maintenance or 6-monthly maintenance, depending on the process industry or the process conditions. But how do we minimize that? How do we minimize those failures and then ultimately reduce fugitive emissions? So the most simple and route one cause or route one solution is to eliminate causes. So Oxflow have our own ES series axial flow control and isolation valve. So this is a, as I say, isolation control valve, but it is emissions free by design. So we go back to the reference that EPA Environmental Protection Agency report saying 80% of the leaks that come from valves come from a valve stem. So the way to get rid of those 80% leaks is to remove the stem entirely, and that's what we've done here. So we've removed any sort of dynamic seal interface to atmosphere. There's no stem, it's just hydraulic lines. We've essentially moved that stem into the valve itself, where there is very little chance of process fluid leaking to atmosphere or hydraulic fluid leaking into the process fluid. We also have our IM range of gas pressure regulators. So these are commonly used in gas transmission and distribution purposes, but also lots of different process industries, tank blanketing, and also hydrogen as well, which I'll come on to later on. So main point of all of these products is that the whole things, in the whole assemblies, there are no stems, no main body diaphragms, and therefore no external dynamic seals, which is very, very important. It's what differentiates us from almost everyone else on the market. And I will say as well that the ES valve in 2022 was the winner of the ASME Best Mechanical Engineering Innovation Award in OTC last year. So that is a really powerful award there, because the reason that this valve won was because of the inherent emissions reduction in this valve design, which is a game changer. So we've talked about this. Actually, it's quite a simple thing for a lot of people to fix. Just use emissions-free equipment. So we've not just gone through. These aren't just designs. They have been installed, they have been working, and they have been shown according to the ISO fugitive emissions 15848 standard for control valves, that these, especially the ES valve, is emissions-free by design. That has been tested as such. It's achieved the highest rating possible by a very high margin when tested with helium, which helium is the smallest molecule, the smallest element that we can test with, that anyone can test with, because even though hydrogen is H1, it's one single proton, it always exists in H2, which actually means its molecule size is slightly larger. So testing with helium and proving that we are the most resistant and emissions-free for that control valve is incredibly powerful. I should say as well that the regulators have also gone through the same level of testing, even though there is actually no specific standard for fugitive emissions testing for pressure regulators. Actually, we've gone through a very extended range of testing with external test houses to make sure that we are, and all of our technology is suitable for future-proofing systems by making sure that emissions are eliminated at the root cause. So that's about enough on emissions there. But let's talk about hydrogen. So I'm sure a lot of you are very familiar with hydrogen, but for the benefit of those who aren't and have just joined in this webinar for knowledge, then I'll give you a very brief overview of hydrogen as a fuel, as an element, and as why is it relevant today. So the reason that everyone is talking around hydrogen is that it is a clean alternative to methane, natural gas. Hydrogen has been talked about as a fuel for a very long time, and it has been around as a feedstock and as a fuel and chemical in process and paint production in many other industries for many years. So it's been around for a very long time, but only recently has it been thought of as a clean fuel for the rest of the world to use. So residences, commercial housing, industrial consumers. This is the time that now hydrogen is being looked at, because it is estimated to contribute to 75% of the mass of the universe. It is one of the most abundant elements that there is. And also burning hydrogen produces no carbon dioxide. Burning natural gas, oil, other kind of fossil fuels, petrol, diesel, and they all release carbon dioxide and other kind of nasty emissions as well. So releasing it into the atmosphere isn't the greatest thing, but hydrogen, when you burn it, releases no carbon dioxide. It's a clean burning fuel. Even releasing hydrogen into the atmosphere itself has no greenhouse effect. So if you do have leaks, it's not going to contribute very heavily towards global temperature rises and climate change, so far as we know anyway, as far as I know. However, producing hydrogen at scale to replace fossil fuels in their entirety has its challenges. I've written 3 very simple things here, but that is by no means a exhaustive list. So there are economic challenges. So first of all, producing hydrogen and selling it on at a rate that is useful to a consumer is not easy at the moment. At the moment, the maths from utility networks and from various money-saving expert in the UK, which is a consumer benefits website, says that actually using 100% hydrogen without government subsidies, you have to use 3 times as much hydrogen to get the same, to heat a litre of water, for example. You have to have 3 times as much. So who's going to be paying for that? Is the end user going to pay for 3 times as much gas, or is the price of hydrogen going to have to come down by 3 times to match what is there at the moment? So lots of economic challenges as well. On the physical side of things, hydrogen is a very interesting fluid. There are several major incidents throughout the history of this element, which means it is physically hard to contain. Hydrogen will leak through metal, leak through joints, it will leak through anything you want. But that has to be overcome, but it is a challenge. But then also safety aspects of hydrogen, which, depending on who you talk to, is the most, for me personally, but for Ultraflow as well, is one of the most important, or is the most important aspect of these kind of challenges that are there. So the safety of using hydrogen. I mentioned incidents in the past, very famous incidents, but also if hydrogen is to be used in natural gas networks, for example, all of the people who work on natural gas systems have to be trained, have to be aware that hydrogen is a different fuel and will react in a different way than natural gas or methane. Natural gas into homes is generally very, very safe. That said, there are very few containment issues around natural gas. There are, but into homes, there are very, very few incidents that happen. And it's very likely that the same will happen with hydrogen, but the world has to be aware, and that is why a huge amount of work is being done by utility networks and energy producers all over the world. Oxflow is working very heavily with SGN, one of the biggest UK gas transporters and distributors, in their research and development into making hydrogen absolutely safe for from everywhere from the production side of hydrogen all the way through to burning it in your kitchen and in boilers in residences and industrial properties as well. So I'll come on to those slightly later on, but I'll just remind everyone that it is still Pride Month for another couple of days or until tomorrow. So I thought it may be quite an interesting one to take you through the hydrogen rainbow. So to give you some background into this, hydrogen production is changed, and the type of hydrogen, how it's produced, is divided into different colours. Actually, a lot of them don't correspond with the actual colours of the rainbow, but it's called the hydrogen rainbow because there are so many colours available. But I'll start off with what is currently the most abundant form of hydrogen that's produced. So this is grey hydrogen. So that's produced from fossil fuels, from steam methane reformation, SMR. So that does have a carbon footprint associated with that. It releases carbon dioxide into the atmosphere, and it's generally, I think as of last year, contributed to 95% of hydrogen production. So not exactly, moving the transition on, but it's a stepping stone. The ideal, where everyone wants to be with their hydrogen production, is green. That is electrolysis using large-scale electrolyzers powered by clean energy, so solar panels or solar power or wind energy. So those renewable energy sources power the electrolyzers, which essentially crack water into hydrogen and oxygen. And the hydrogen is pumped into whichever lines or storage or tube trailers. That's the way it goes. But green hydrogen is the ideal. Unfortunately, green hydrogen at the moment is a little bit more expensive quite a lot more expensive than grey hydrogen. But that is coming down all the time through to as a result of all of the investment and all of the technologies being put towards green hydrogen. That price is coming down reasonably quickly. But to meet the energy needs of the UK and of the world, there needs to be a bit more of a stepping stone. That comes in the form of blue hydrogen. So that is using the same hydrogen production method as grey hydrogen, so steam methane reformation, SMR, but the CO2 is then captured at the end. So CCUS, carbon capture, utilization and storage, is utilized to make sure that any CO2 emissions are not released into the atmosphere and they're not causing further damage to the environment or anything like that. The next one, which is even worse than all of grey and even worse than grey, is black and brown, which is essentially coal production of hydrogen, which we want to stay away from. It's damaging to the environment, so that's ideally what we don't want to do at all. There's also pink, which is similar to the green form. It's still using an electrolyzer to crack water into hydrogen and oxygen, but that is now powered by, instead of renewable clean energies from, instead of energies from solar or wind or tidal, then it comes from nuclear power. So lots of nuclear power stations are being commissioned. There's a wide and very ready form of energy. So that is also a very is going to play a massive part in the energy mix going forwards. And then quite a new one is turquoise hydrogen, which is methane pyrolysis. So I won't go through this in that much detail because I only found out about this not too long ago, so I'm still trying to get my head around how it works, but it's a reasonably new one. Yellow hydrogen produced through solar power, very specifically through solar power, and then white, which again I only learned about reasonably recently, but that is naturally occurring geological H2. So that exists, you know, in rock formations as it is at the moment. There aren't massive reserves of this, and you would have to get into it via fracking or similar methods, which, you know, I won't again get into the politics of right now. So that's an overview of the hydrogen rainbow of various different colours. It is very possible that going forwards in the future, there will be a multitude more of these different colours associated with hydrogen production, but I'm not going to try and present them now. So we'll come on to hydrogen emissions. So emissions revisited. So I mentioned before that hydrogen is actually one of the hardest chemicals to store and transport at scale. You know, usually, as I said before, hydrogen has been around for a very long time. As a feedstock, as a fuel, as an industrial fuel. But transporting it and storing it in the industrial scales that we're going to have to is going to have its challenges. So it's particularly difficult on pressure reducing equipment and pipeline technology. You know, especially at large bore in large bore pipelines above kind of 2 or 4 or 6 inch. So that's DN 50, 100, and 150. Above those sizes, you know, it will present huge issues. So leakage is, again, leakage, i.e. emissions. I've mentioned before, hydrogen can in cases leak through metal itself. But anywhere where there is a joint or an elastomer, that can struggle with hydrogen as a seal. So lots of kind of elastomer and sealing OEMs have gone through huge testing processes and R&D processes to try and sort out sealing with hydrogen, you know, in up to 1,000 bar of pressure, all the way down to millibar outlet pressures. But hydrogen is an issue at every stage. So using equipment that has hydrogen-resistant elastomers and metallurgy will really help. One of the issues as well is just around a phenomenon called embrittlement. So anywhere where there's a ferritic steel, if there's a steel pipeline involved or steel components, embrittlement can occur. And that's where hydrogen essentially can seep into the crystalline structure of steels themselves, react with carbon within those crystalline structures and create methane. So those that production of methane within the steel walls themselves can lead to stress cracking and eventually a failure in the pressure containing components. So the choice of material that you use for any of these kind of difficult conditions really does make a difference. And obviously all of that leads to the safety implications. You know, leaking hydrogen can pose serious safety issues for consumers, transporters, producers, anyone who works on a hydrogen pipeline. It will pose safety implications for them. And yeah, as I said, this is not an exhaustive list. There are plenty more coming, and plenty more that are being researched and fixed as we speak. But again, this is one of the results that come. We don't sort out leakage. It's instead of natural gas or something which is reasonably easy to vent off or to divert away from a production site. Hydrogen is defined as aggressively buoyant and will ignite at any point. It's very ignitable as opposed to natural gas, which only poses a danger in certain very low concentrations. So the solution, you can probably see where I'm going here as a manufacturer of pressure containing equipment and pressure control equipment, is just use hydrogen-ready equipment. So the right equipment with the right knowledge does and will go a long way towards making hydrogen usage en masse usable, possible, and safe. So that would be through our own technology. Obviously, there are other manufacturers out there who've been doing this for a very long time, but Oxenflow have been doing this with innovative ways of working, doing, basically rewriting the rule book in how to design pressure and flow control equipment for these kinds of industries. And it just so happens that we are perfectly placed to help out with hydrogen projects going forwards. And I'll come on to a few details of those going in the next few slides. But much more needs to be done. We are one manufacturer and we can't change the course of history by ourselves. Governments, international standardization, that's all required to make sure that the entire world moves forward so we can address these challenges together and with a unified direction, because without that, progress will be quite slow. If everyone is trying to do their own thing to try and make their own equipment hydrogen ready in their own way, or thinking that the industry is going to go one way and then it goes another, that just stalls progress. So research, testing, verification, all of the kind of knowledge that's being built up needs to be performed and shared. There is no point in everyone performing all of this research and not sharing it with the world so that they can do something with it, so that we can all, as a collective, move forward and solve the crises that are coming if we don't change our ways. So on that, bit of shameless marketing here, in that Oxenflow as a company do have a lot of hydrogen initiatives going on. So we have independently completed extended hydrogen and helium testing to make sure we are ready for whenever that transition comes, whether it's going to be start off with 20% mixes into natural gas, but then all the way up to 100%. That is something that we are prepared for. So all of our equipment has gone through an extended range of hydrogen and helium testing with external test houses. We've also partnered with the LTS Futures Committee, LTS Futures team within SGN, who have selected our equipment and control valves for their 100% hydrogen verification of the UK high pressure gas networks. So that is repurposing all of the existing, the aim of it is to repurpose all of the existing natural gas pipelines over towards hydrogen. So we have been very specifically selected to help with that, because we do have fugitive emissions-free technology, and also it's hydrogen ready from its construction, from its metallurgy. It's all 316 stainless steel, and all of its elastomers have gone through kind of automotive standard for hydrogen rapid gas decompression. So obviously I've talked about hydrogen mainly, and I realise we're running slightly out of time. I've got 3 minutes left to go through other renewables, but this is not limited to hydrogen. So I'm going to essentially show you the new energy system. So this is basically a power to X graphic that I've picked here from PowerMag, and this essentially lines out all of the, from green electricity, from renewable electricity, hopefully, or from the grid, wherever that comes from, whether it's coal power stations for the time being, though ideally not for much longer, nuclear power, renewable electricity, offshore wind, that goes through an electrolyzer, develops hydrogen, oxygen, CO2 is produced in some of this, but it's also, there's every little arm of this, but we produce products that can go in every sort of section of it. So I've put together a very messy graphic of where all of these products can go. So by all means, don't make me explain this in its entirety, but if you have projects ongoing in any of these sections, then by all means, please get in touch with us, and we will find, we will help you find a solution. We have any products from energy harvesting devices for liquids, so for reverse osmosis, filtration for an electrolyzer. Half of the water that goes into an into a reverse osmosis filtration skid is thrown overboard. Is then kind of it's dumped over. But waste lines can be fitted with energy harvesters, which again charge up batteries. It's all renewable electricity. And we also have our liquid regulators for the liquid side, water side, through to the electrolyzer, through to everything else as well. So I won't explain this too much, but this is a small representation of this Power-to-X system. And also biomethane, ammonia, THPs, peaking power plants. All of these sectors can really benefit from, and have really benefited from, OxyFlow equipment. So it's all just benefiting and building up that knowledge that we have to carry on. I would like to thank all of you for your time. And in the meantime, here are my contact details. If you have questions that come up later, please follow us on LinkedIn. There's usually some very good content that comes up almost daily. There's new press releases and new information coming along all the time, especially around the hydrogen transition and the work that we're doing there. But otherwise, I shall leave you. Thanks very much, everyone. Bye-bye.